This is section 2 of chapter 7 of probability and statistics. Our topic today is probability. Our essential outcome is that you will be able to understand probability and find the probability of events. So, first things first. When we are figuring out probability, there's a few different ways we can do it. We're going to talk about theoretical and experimental probability as we go through this. And with probability, we typically don't just do an experiment once. We do an experiment many, many, many times. And the reason why we do it many, many times, if we look at this proportion of heads and the number of tosses, well, the first time they flipped the coin, they got heads, and so they think that the probability of getting heads is 100%. And you can see how the graph changes the more times we do it, and eventually it gets close to this probability of 0.5, of 50%. And we all know that the probability of flipping heads on a two-sided coin is 50%. There's two outcomes. It's 50% to get heads. And so as we do probability, when we get into our experiments, we're going to do it many, many times. And the reasons why we like probability and why we use probability is it helps us predict events. It helps us know what some of the possible future outcomes are. And so, definition of probability: it's the proportion or fraction of times an outcome occurs in the long run over many trials. And so there's two things to talk about when we're talking about probability. We talk about sample space, and that's all the possible outcomes in an experiment. And then we talk about the event, and that's the specific outcome that you want to have. So probability is the fraction of the time an outcome occurs over all of the possible outcomes. And so we talk about these two terms in that: sample space and events. Alright, so probability. First we start off, this is our probability equation. It's the probability of A, this is the probability of some event, and it's written as a fraction. So in the numerator we have the number of times event A occurs, and in the denominator we have the total number of outcomes possible. And so if we look at the spinner down here, what is the probability of spinning the green space on the spinner? Well, if we look at it, how many different outcomes are there? I can get purple, green, red, or orange. So there are 4 outcomes. So my fraction, 4 is going to go into the denominator. How many of these outcomes are going to give us the green space? Well, only one of them will. So our probability for this one is 1/4. And remember, you can write probability in 3 ways. You can write it as a fraction, a decimal, or a percent. All of them are acceptable. If a question does not specifically ask you to write probability in a certain way, you can write it in any of these ways. Sorry, my pen is not working for me right now. I think it's because I need to move the spinner. Alright, anyways. So there's 3 basic rules to probability. First basic rule: probability answers must land between 0 and 1. Okay, probability of an event being 0 means it's impossible, it can never happen. The probability of 1 means that it has to happen. And so the higher that your number is, the better chance it has of happening. All the probabilities of the sample space must add up to 1. And probability of an event not occurring, the probability of A prime, is 1 minus the probability of the event. This is sometimes called the complement. Okay, and if you remember from some of our different notations, we talk about the not with this little c right there, or with this prime notation. So if you see those, that's the probability of it not happening. So here we have some basic situations. It says, what is the approximate probability that it will rain today? Well, I can look that up on my phone, or you can look it up on your phone and look up what the probability is of that. And it looks like the probability of it raining today is about 42%. So there you go. You can also think about it, okay, well, if you didn't know, it's either going to rain or it's not going to rain. And so, you know, if you don't really know, you got about a 50% chance that it's going to rain that day in the summer. What is the approximate probability that the sun will rise tomorrow? Well, seeing as how the sun rises every morning, I would say that the probability for this is going to be pretty close to 1. Or 100%. What is the approximate probability that it will snow tomorrow? Well, for me, it's currently June 25th. It's not really going to snow tomorrow. It's supposed to be in the 80s. So I think it's pretty much a 0 probability. What is the approximate probability that there will be a volcanic eruption here today? Well, seeing as how we have no volcanoes in Minnesota, the probability of that is very, very slim. It's going to be 0. Or something close to 0. And so those were just things that we didn't have an actual thing in front of us to look at. But here we have some situations that we can actually we can look at all the possible outcomes. So if you have a 6-sided die and each side's numbered 1 through 6, what's the probability of rolling a 4? Well, only one of the sides is going to be a 4, and there are 6 possible sides, so that's 1/6. If we're looking at a deck of cards and we want to know what's the probability of choosing a red card, well, we know there are 52 cards in a deck. And of those 52 cards, 26 of them are red, so 26 of them are going to be our event, 26 out of 52. Coins. What's the probability of getting a head on when you're flipping a coin? Well, there's 2 outcomes. You can either get heads or tails, and one of them is a head, so we get 1/2. If we look at our spinner down here, what's the probability of getting orange? Well, there's 4 outcomes, and one of them is orange, so it's just going to be 1/4. Alright, so if you're going to do an experiment, you say, what is the probability of getting 3 heads in a row and flipping a coin? There are a few things you need to do. First off, when you're coming up with your plan of attack, you need to figure out the sample space. How many different ways can I flip 3 coins? So let's type that out. We could start off with a heads, and heads, okay. And then maybe we'll get a heads, tails, and heads. And maybe we'll get a heads, and tails. And we could get a heads, tails, right? All those started with heads, and I think those got you have 4 combinations there. We'll now see what if our first flip is a tails. I get tails. Then I get heads. Now I'm gonna get tails, heads. Now tails, heads, tails, and tails. There you have your 3 different ways. These are your 8 different ways to flip 3 coins. So now we know the sample space, and now we need to find the number of desired outcomes. Okay, so it says, what is the probability of getting 3 heads in a row and flipping a coin? Well, out of all these outcomes, only one of them gives us our desired outcome. That's right here. Alright, so we have that one of them is our desired outcomes. And then we need to actually answer the question. So what is the probability of getting 3 heads in a row and flipping a coin? Well, we know that one of them gets us what we want, and if we count up, there were 8 different outcomes, so 1/8. What is the probability of flipping 2 tails and 1 head? So this time we're going to use yellow. We want 2 tails and 1 head. So here we get 2 tails and 1 heads, 2 tails and 2 tails. So there's 3 of them that we want, and there's still 8 outcomes. What is the probability of flipping at least 1 tail? So let's talk about that first. If it's at least 1 tails, we can have 1 tails. Could we have 2 tails? Is that at least? Yeah. Could we have 3 tails? Yeah. So let's go through and look through these, okay? Here's at least 1 tails, at least 1 tails, at least 1 tails, at least 1, at least 1. It looks like we got all of them except for we got only heads, so that's 7/8. And there you have it. Alright, so when we talk about probability, there's a few myths, alright? One's called short-run regularity, and the myth is that in small samples, the outcome will always follow the predicted probability. So the thinking behind that is if you're flipping a coin, okay, the probability of getting heads and tails is 50% for each. So they think that if you flip a coin 3 times, and you get heads for all those, you're probably going to get tails for the next 3, but that's not true. Once you do an experiment enough times, okay, some of that starts to happen, but if it's short run, if it's a small chunk, it's not going to always follow the predicted probability. The other one is the law of averages, and it's the myth that future outcomes must make up for an imbalance in current results, and that is not true. Everything does not always average out. Alright? So, the myth of short-term regularity, what we talked about is this is the misconception that since randomness is predictable in the long run, then it should be predictable in the short run, but it is not. So we look at these two different heads and tails combinations. Which of the following outcomes is more probable? Well, they're the same. They're the same amount of probability. They're both as equally likely as the other. All right, and the myth of the law of averages. So we've got this is just a little comic. It says, so the law of averages doesn't guarantee me a girl after 7 straight boys, but can I at least get a group discount on the delivery fee? So if we think about, okay, this woman's already had 7 straight boys. Is she more probable to have a boy or a girl? It's still a 50-50 shot. Just because she had 7 boys does not mean she's more likely to have a boy or a girl. And that is the end of Lesson 2 of Chapter 7 of Probability and Statistics. Write your summary and your questions. The essential outcome for today is that you will be able to understand probability and find the probability of events.